Hey, how's it going? Jeff Blatt from Team Brita here. We're going to be testing some water today and wanted to invite you guys along. So ultimately what we're going to be doing is we're going to be comparing two different types of water today. You have raw city tap water. We're in Round Rock today, Round Rock, Texas. And we're going to have filtered water. So this is a miniature water softener, if you will. Look at the most bare bones level. You're going to have an active ingredient in there called resin. We have some carbon mixed in there as well, and that's just to show you what's going to happen is when you have water running through the tank, the contaminants and hardness in the water are going to cling to the media in the tank just like metal would to a magnet. So all the bad stuff's going to stay in here, and out comes filtered water, and the whole point of us doing that once again is to show you two different versions of water today. So first test that we're going to run is the TDS test. Ultimately, TDS is a measure of the combined total of organic and inorganic substances contained in a liquid. So what we're going to do, I always like to start my tests off with bottled water as a benchmark for what a good quality water is supposed to look like. So we have some Kirkland water here from Costco. And what we're going to do is we're going to pop this in here. You can see a bunch of zeros on top. We're going to pop that in there. And usually what we'll see is bottled water is going to be between about 5 and 30 parts per million of solids in the water. And this is lining up perfectly. So this is at 22 parts per million. And that's saying it has 22 parts per million of solids in this water that aren't actually water itself. So now what we're going to do, so that's bottled water. Now you've seen what it's supposed to look like. And this is a good quality water for us to be consuming and putting in our body on a daily basis. Ultimately, I'll tell you this much: you don't want zero water. All right, zero water is going to be, your evaporated water or distilled water. There's nothing in that water for your body to absorb, so it ends up dehydrating you overall if you're using it as your day-to-day drinking source. So that's not something that you want to be drinking on a daily basis. You want to have some sort of solids in there. But now what I did is, if you notice, I took a bit of the tap water. Once again, this is your Round Rock City tap water. Bunch of zeros on top. Pop that in there. And looks like we're hanging around 200 parts per million of solids in this water that aren't actually water itself. And keep in mind, when we're talking about solids, that could be things like calcium magnesium is a big one that everybody's heard about. You have the organic and inorganic version of calcium magnesium. The inorganic version is like biting into a limestone. The organic version is like taking a calcium magnesium pill where your body could actually process it. Inorganic calcium magnesium ends up turning into things like kidney stones. If you ever go to the doctor with kidney stones, first thing your doctor is going to tell you is stop drinking tap water, stop drinking refrigerated water, because it's your body can't process it and it just lingers around. So those are some solids, though. Once again, other than calcium magnesium, you're also going to be running into things like heavy metals, fluoride, arsenic, lead, nitrates, cadmium, chromium, things like that. So now what we're going to do, we're going to take a sample of the refrigerator water. A lot of people use the refrigerator water as their primary drinking source. They say, hey, I have a filter in there. Should be a good quality of drinking water, right? One would assume. So let's do this. This is what we're going to do now. We're going to do your refrigerator water. And you can see a bunch of zeros on top. And let's see where this is. So 170, okay? So it took a little bit out from what's coming out of the tap, okay? But you can see there's still quite a few solids in there that are making its way through the carbon filter into your glass of drinking water. And the whole point of us doing that test is to really show you that the refrigerator filter is not doing what people really think it's doing most of the time. The refrigerator filter is a carbon filter. Carbon's great for certain things. Carbon's really designed to more so remove the chlorine out of the water. Chlorine is what makes your water taste bad and smell bad in the first place. So by removing the chlorine out of the water, that water is going to taste different than this water. So people get the whole placebo effect, if you will, that they're drinking filtered water, but in reality you can see all the other solids are making its way through that filter and into your glass of drinking water. So that's just to kind of show you a little bit about what's coming out of the refrigerator and versus what's coming out of the tap versus what's coming out of bottled water.